next things we studied is this motion possible by using the host gas droplet, meaning the host liquid crystal and gas light absorbing molecules? Because if this motion was only possible for MBBA, there will be not so many options. But if we can induce the dye-induced dye-doped liquid crystal, we can think about many combinations of the photocontrollable active droplet. That's why next one we try this one. So as I mentioned, MBBA has photoresponsiveness, and also it itself is liquid crystal. But in this case, liquid crystal with some gas molecules, and these gas molecules has photoresponsiveness and induce some change. So in this case, we use a dye-doped liquid crystal because there are many types of the different type of the dye-doped liquid crystal. And the formation mechanism for the preparation of sample is totally same. We use a microfluidic device and in an outer fluid encounter at the center and induce the shear force to generate this kind of droplets. And in this case, we use two types of the liquid crystal droplets. The host liquid crystal is 5CB, which is one of the most typical well-known liquid crystal. But we change the gas dyes. One is a BHAB and the other is BMAB. The difference is both of them are basically azo dye, but at the end of the molecules, BHAB has OH, but BMAB has OCH3, and obviously this one is hydrophilic and this one is hydrophobic. And we use our SDS solution as an outer fluid. And observation setup is also same, and we observe the motion by using the inverted microscope and observe the UV LED was illuminated with some angle. So here's a demonstration. Surprisingly, when we illuminate the UV light to the BHAB doped 5CB moved away from the UV light source. Actually, when it's on, it's moved, off, it's stopped, like this. On the other hand, in the case of BMAB, when the UV is on, it's moved toward the light source, same as MBBA, and off, it's stopped, and then on, moved again. So the thing is, we could successfully control the motion, and also surprisingly, by just changing the small molecular structure of the doping dye, we could control the direction. And then next thing is we confirm the convective flow inside the droplet. So what we observe here is we could see inside the flow direction for BHAB doped and BMAB doped. And obviously the flow direction was opposite. So that's the cause of the motion direction. And how could it be possible by just changing the dye molecules? So we again studied how the solubilization occurred during the light irradiation. So what we did is we illuminate the liquid crystal droplet, and the UV was irradiated, and then sampled every several tenths of a second to measure the absorption spectrum. And what we found here's the things we can observe the 5 CV absorption around 280, and either BHAB or BMAB both has absorption around 350. So what we noticed is in the case of BHAB, the 5 CV was solubilized outside, but also BHAB was also solubilized into the outside. On the other hand, in the case of BMAB, 5 CV was solubilized, but BMAB was not. So only BHAB was solubilized to outside, and BMAB was not. So this difference, solubilization difference, could be could have some relation with motion direction. Then we studied the surface tension change by illuminating the UV light by using the pendant drop method. So what we did is we prepared the droplet, pendant drop, by the dye-doped liquid crystal in the surfactant solution. And then UV was illuminated to measure the surface tension change. And what we found is in the case of BHAB doped 5CV, when the light was illuminated, surface tension increased. On the other hand, BMAB case, when the light was illuminated, the surface tension decreased. Meaning that in the case of BHAB, some desorption happened from the interface. On the other hand, absorption happened, and in the case of BMAB, droplet case. So from the surface tension change experiment, we could observe the totally opposite phenomenon happening at the interface in the case of BHAB and BMAB doped liquid crystalline droplet. So what we could understand is in the case of BHAB doped 5CV, as you can see, BHAB has OH functional group, and you could easily imagine that this molecule could absorb the surface because the OH is hydrophilic. And then when the light was illuminated, after the molecular structural change was dissolved in outside. On the other hand, in the case of BMAB, methyl group as hydrophobic, so these azo molecules tend to stay inside, but somehow after UV irradiation, due to the probably polarity change or of molecules, it could absorb as an interface that decrease the surface tension. So here's a motion mechanism we could propose. So when in the case of BHAB, when the light was illuminated, the desorption happens, and then this surface tension gradient induced counterclockwise motion direction flow. On the other hand, in the case of BMAB case, the once the molecules are absorbed at the interface, it could induce opposite direction of the convective flow. That's cause the motion direction totally opposite. So here's a summary too. We could control the motion of the dye-doped liquid crystalline droplet. And the good thing is we could change the motion direction just by changing the minor molecular structural change of the dye